This is our fourth video on polynomial inequalities. And if you have missed our previous 3 video tutorials, go check out our playlist on this topic. So in this example, we have x to the power of 4 minus 1 multiplied by x minus 4 squared smaller or equal to 0. And this example builds on our previous video where we had x minus 4 squared bigger or equal to 0, and I explained why that equation would always be positive. So in this video we have x to the power of 4 minus 1, which is a difference of squares which we can factorize. And when I factorize that bracket, I have x squared plus 1 times x squared minus 1, and I keep x minus 4 squared by itself. Now I notice that my middle bracket is also a difference of 2 squares, which I can factorize. So when I factorize further, I have x squared plus 1 times x minus 1 times x plus 1. So that is x squared minus 1 factorized. And then I have x minus 4 squared smaller or equal to 0. Now we have factorized the expression fully, and we can use these brackets to find our critical values. So in our first bracket of x squared plus 1, for the critical value, we have x squared is equal to negative 1, and therefore x is equal to plus or minus the square root of negative 1. And this value does not exist on a number line. So for an inequality, this is not a valid solution. And if we set our second bracket equal to 0, we have a critical value of x equal to 1. And our third bracket equal to 0 would lead to x equal to negative 1. And our final bracket equal to 0 would lead to x equal to positive 4. So from this expression, we have 3 possible critical values of x equal to 1, x equals to negative 1, and x equals to positive 4. Where the first bracket gave us no real solution that will exist on a number line. So our next step is to plot these values on a number line. So after I've plotted these values on a number line, which represents the x-axis, I want to determine where the expression would be positive. So I would consider the value to the right and to the left of positive 4. And in our previous video, we learned why x minus 4 squared would give us 2 positive values to the right and to the left of 4. That means that this expression would be positive after 4 and positive between 4 and positive 1. Now we will go back to our pattern of negative and positive. So remember, in our first lesson, we learned that our number line would fluctuate between negative and positive. But when we have a squared value, the sign is repeated for that specific critical value. Now the question is, where is this expression smaller or equal to 0? And that's only for the section on the number line where we have a negative. So x must be smaller or equal to positive 1. And x must be bigger and equal to negative 1.